Okay, so there are two topics that I want to talk about today. First one is atomic structure, which is something that is nothing new for us. And the second one is how you calculate the AR. So first thing that you have to understand is कि atomic structure है क्या and atom में होता क्या है. So there's a whole history behind it, how people figured it out. And it's a very interesting process. It took us almost 2000 years to figure out कि atom कैसा होता है. And even after knowing कि nucleus जो है वो छोटा होता है, center में होता है, positive होता है, उसके बाद भी हमें 30 साल लगे just to figure out कि उसमें protons होते हैं, neutrons होते हैं और electrons होते हैं and the way they are. और अभी भी हमें उसके बारे में काफ़ी चीज़ें नहीं पता है. But it's a very interesting journey and amazing insights. और लोगों ने जिस तरह से किया है इसको discover, एक एक स्टेप पे आपको पढ़ के अंदाजा होता है कि कितनी मेहनत का काम है ये. There was this guy Richard Feynman who was a Nobel Prize winning physicist and part of the Manhattan Project जिन्होंने first atomic bomb बनाया था, and he was also a professor. तो उससे किसी ने पूछा कि अगर दुनिया खत्म हो जाए तो और आप सिर्फ नेक्स्ट जनरेशंस को एक सेंटेंस बता सकते हैं कि मतलब everything is gone and annihilated and you can just tell them one sentence, and what is that one thought that you want them to know? And he said that I would like them to know that everything is made of atoms, and that shows how profound the structure of atom is to our understanding of the universe. Anyways, so first thing that we know about atoms is that atoms are mostly empty. They are over 99% emptiness, just like some people. And there are two main things in there. So there's the nucleus, which is at the center, and around it, there's a cloud of negative charge. So हमारे पास center में nucleus है, जो कि बहुत छोटा है, and then around it, you have a cloud of negative charge. So in fact, उसको बनाने के लिए I would just say कि ये बाकी सारा जो है ना, that is the atom. So technically, atom does not have a boundary and edge. We just assume कि यहाँ पे जो है ना उसका influence खत्म हो गया, तो that is where it ends. So this is the electrons का cloud. Why do we call it a cloud? Because it doesn't have a rigid boundary. It's just electrons flying around in random patterns. And this is a really small, dense, positive nucleus. और इस न्यूक्लियस में दो चीजें हैं, and this is again nothing new for us. There's the proton and there's the neutron, and electrons जो हैं उनके अंदर कुछ भी नहीं होता है, ठीक है? They are very fundamental particles. The mass of proton and neutron in kgs is really really small, and in charge भी उसका elementary charge हम कहते हैं उसको. So the mass of proton is ridiculously small, 1.6 into 10 per minus 27 kg होता है. और इलेक्ट्रॉन का मास -20 10 पावर -31 kg होता है, जिसका मतलब है कि इलेक्ट्रॉन इज लेस देन 1000 टाइम्स sorry, proton is almost 2000 times heavier than electron. तो इस वजह से हम इलेक्ट्रॉन को रफली जीरो अज्यूम करते हैं कि उसका मास जो है ना वो नेग्लिजिबल है, इट डजंट मैटर. और प्रोटॉन का मास हम 1 ले लेते हैं, इसका mass हम 1 ले लेते हैं और इसका mass हम almost 0 ले लेते हैं. This is called relative mass. And then they have charges. So this is their mass in atomic mass unit. ठीक है? Atomic mass unit जो है वो kgs नहीं होते, वो काफी छोटा unit होता है. And then they have their charge. The charge on neutron is 0. That's why it gets its name neutral है ये. And the charge on proton is 1.6 into 10 power minus 19 coulomb. And this is the elementary charge in nature. And इससे छोटा charge exist नहीं कर सकता. और every other charge is just a combination of this. Electron पे भी इतना ही charge होता है. It is also 1.6 in 10 power minus 19. The only difference is that the behavior or the nature of this charge is different from that for protons. तो हम इसको positive बोल देते हैं, इसको negative बोल देते हैं. It's just that कि उनका nature different है, but they're equal in number. So examiner यहाँ पे question पूछता है that describe and explain why an atom is neutral. It's a 2-mark question. So what do you think we should talk about?
The charges canceling themselves out.
If we directly say that charges cancel each other out, तो वो बड़ी एक haphazard सी बात है, because you did not introduce कि charge आया कहाँ से, you did not say कि कहाँ से cancel out हो रहा है वो. So it's always a good idea to start by introducing a charge आया कहाँ से. So protons are positive charge, electrons have negative charge, and just this idea will give you 1 mark. And then uh, the number of protons and equals the number of electrons. So that's how we know the charges cancel out. So assuming anything to the examiner, उससे बेहतर है कि हम उसको पूरी डिटेल में खुद से बता दें. Now, one way we can figure out कि इनका चार्ज और इनका मास की रेशियोज किस तरह से हैं is to subject all of this to an electric field. So let's say मेरे पास एक दो plates हैं which are in a uniform electric field, और मैं यहाँ से there's a beam of particles that's coming in. अब अगर तो एक पार्टिकल स्ट्रेट चले जाता है, इट डज नॉट गेट अफेक्टेड, तो हम कह सकते हैं कि ये न्यूट्रॉन है. बट अगर एक पार्टिकल आ रहा है और इट क्विकली रन्स टुवर्ड्स द पॉजिटिव साइड, तो वी कैन से कि ये एक इलेक्ट्रॉन है. एंड इफ अ पार्टिकल इज कमिंग इन एंड इट्स गोइंग लाइक दैट in a parabolic form, we can say that this is a proton. Okay, so a beam of particles will always behave like this in an electric field. Obviously agar aap electric field ki strength badha denge, then they will obviously bend more, they will experience greater force, but unki directions jo hain wo aise hi hongi. The proton will go towards the negative side and negative electron will go towards the positive side, because opposite charges attract. Now, each one of these has a significance when it comes to the structure or the properties of the atom. Electron makes ions. Neutron plays an important role in isotopes. And proton is important to identify the element. Every atom of one element has identical number of protons, but they can have different number of neutrons, and that is how they get different isotopes. If the number varies a lot, or if the number is not just right, तो वो unstable nucleus बन जाते हैं. And unstable nucleuses are called radioisotopes. और radioisotopes release energy. उनमें से न्यूट्रॉन कभी टूट जाता है, कभी प्रोटॉन टूट जाता है, and it gives you different particles and energy all the time. And electrons give it ions, कि वो atom को convert करते हैं into ions, and those ions then react. These electrons, there's a special group in them which we know from O levels, that is valence electrons or outer electrons, which determine the chemical properties of the substance. Physical properties में ये तीनों they play a role, but chemical properties में valence electrons are the most important group. Okay, so the density, the electrical conductivity, ये सारे का सारा तो physical property है. लेकिन whether something reacts or not, that depends on the electrons, and how does it react, that also depends on the electrons. So इस वजह से हमारे पास electrons का एक बड़ा important role है. Now these isotopes that are present in nature for every different atom वगैरह, they have their abundances, and what we do is that we need to give them some mass, and we want to figure out their relative atomic mass. तो हमारा एक स्टैंडर्ड है, एक हमने चूज किया हुआ है, दैट इज कार्बन 12. सो कार्बन 12 इज द स्टैंडर्ड, एंड वी गिव इट अ मास ऑफ एग्जैक्टली 12 यूनिट्स. इसको हमने मास दे दिया. तो एवरी अदर मास वी आर गोइंग टू कंपेयर रिलेटिव टू दिस 12. सो 12 तो वो है, लेकिन हाउ मच विल बी 1? 1 will be 1/12 of this. So we have a relative idea that the unit is 1/12 of carbon 12. Carbon 12 का mass 12 है, तो 1/12 of that will be 1, and that is our unit. So the unit that we have is this. इसको हम atomic mass unit बोलते हैं. अच्छा. So there are many different relative masses that we can figure it out from this. So there's the relative atomic mass. तो relative mass में हमारे पास relative atomic mass है. We have the relative isotopic mass. We have the relative molecular mass. And you can have other masses as well. Like you can have relative formula mass. ठीक है? और हर एक की अपनी अपनी significance है. जैसे Relative atomic mass is the mass of an atom compared with 1/12 of carbon 12. Relative isotopic mass is the mass of any particular isotope of an element. तो हम सारे atoms को नहीं कर रहे, उस element को देख रहे हैं, compared with carbon 12. Molecular mass will be for molecules as the name suggests, तो वो covalent substance होगा. And formula mass will be for ionic substances, तो वो किसी ion का या किसी ionic compound का relative mass होगा. उन सब में common बात यही है कि they are all compared with carbon 12. Just to understand whether you know what ये सारी बात क्या थी. Can you tell me the number of protons, neutrons, and electrons in this particle?
Sir, the proton number is 16, neutron is also 16, and electron is 18.
That's correct. That's correct. So that's how we know different particles, and we can obviously this is an isotope of 32. But in the periodic table, you will see कि आप S32.1 होता है because this is the relative atomic mass. Now, how do you figure this out? We use a technique called mass spectrometry. अब how does a mass spectrometer work? It's a machine. हमें उसकी डिटेल में जाने की जरूरत नहीं है. We just need to know कि उसमें एक गन होती है. That gun is used to make ions from atoms. And then those ions are accelerated using electric and magnetic fields. Why do we use ions and not atoms? Because atom जो है वो किसी electric field में deflect नहीं करता, लेकिन ion करता है because ion के ऊपर charges होते हैं, तो electric magnetic field में वो respond करता है, atoms नहीं करते. So what we do is that we feed the gaseous atoms into the thing or molecules, उनको हम ions बनाते हैं by simply removing an electron. And that means कि अगर मेरे किसी चीज का mass है 32 और मैंने उसमें से एक इलेक्ट्रॉन रिमूव कर दिया तो उसके पास बन गया mass उसका +1. Sorry, charge +1. So if I divide the mass by the charge, it gives me 32/1, which is 32. That's the atom, atomic mass. But now it's a ion, तो मुझे वो bend होता magnetic field में इस तरह से करता नजर आएगा. But करना क्यों है ऐसा? Why can't we just use the atom directly? So it's kind of like, imagine if there was a fan that was blowing and you had 5 different balls of white color. And you want to check इनमें से golf ball कौन सी है और ping pong ball कौन सी है. तो 5 हैं तो आप तो उनको उठाओगे, weigh करोगे, पता लग जाएगा. But if you have 5 million of those and you want to separate golf balls from ping pong balls, तो उसके लिए आप क्या कर सकते हो कि there's a fan blowing, you can take those balls and you can throw them out. अब obviously वो fan क्या करेगा, पिंग पोंग balls को तो वो डिफ्लेक्ट कर देगा, लेकिन जो golf ball होगी वो उसके सामने से डायरेक्ट गुजर जाएगी. So the ping pong ball is going to travel less distance, the golf ball is going to travel more distance. So अगर यहाँ पे वो fan है तो golf ball तो डायरेक्ट चली जाएगी, पिंग पोंग बॉल जो है वो ऐसे रुक जाएगी. And then at the end you'll be like, अच्छा इतनी मेरे पास पिंग पोंग बॉल्स इकट्ठी हुई हैं, इतनी मेरे पास गोल्फ बॉल्स इकट्ठी हुई हैं. You can easily compare them कि अच्छा ये इतने percentage of these balls were there in the bigger bucket that you had. And that's exactly what we're going to do with the ions. And we don't have a fan anymore, we have a magnetic field. And we don't have golf balls, we have different isotopes. And we don't have the number of balls that we collect, we have relative abundance of these things. So हम क्या करते हैं, हम इनको इसी तरह से different buckets में collect करते हैं based on कौन ज़्यादा deflect हो रहा है, कौन कम deflect हो रहा है. जो ज़्यादा deflect हो रहा होता है उसका मतलब ये है कि उसका mass different है, क्योंकि सबको charge तो हमने एक जितना दिया हुआ है. Of course charge change करोगे तो deflection change होगी, but just because हमने एक जितना charge दिया हुआ है तो we assume कि भाई वो इसी तरह से चल रहा है. सबका यूनिफॉर्म चार्ज है, mass different है, deflection से पता चल जाएगा. And that's what we do here. So we do all of that. हमारे पास different isotopes आते हैं. Let's suppose magnesium की example लेते हैं. So magnesium के different isotopes हैं. There's magnesium 24, magnesium 25, magnesium 26. Now if you throw them in there, obviously you'll get 3 buckets और उसके बाद आप उनका graph बना सकते हो. In fact, the computers that are connected to those machines, they automatically make the graph for us. So let's suppose मेरे पास 24, 25 and 26 तीन levels पे ही आएगा. And this is called mass to charge ratio. Why? Because the mass is 24, charge is plus 1. So 24 over 1, 24. So technically तो मुझे mass बता रहा है, but charge has to be there because without charge, this thing will have a different graph. If I change the charge to plus 2, graph completely different हो जाएगा. And on this scale, I have the percentage of those that we found. And this is called abundance. So let's suppose मैं graph बनाता हूँ और इस lines की different heights आती हैं. ठीक है? So I'm not drawing this to scale, but let's say this is 10.1, this is 11.3, and this is 78.6. And this is actually not the height. It is technically the area under this peak. ये peak होगी और इसके नीचे कुछ area होगा और वो area हम calculate कर रहे होते हैं. But अभी के लिए, because it's a very fine line, so 78.6 is the value for that. And this is the abundance. It's the area under the curve. And in A2, you do talk about the area under the curve. But overall, this is what you get for magnesium. So I want to figure out the relative atomic mass, which we write like this. So all I have to do is multiply the abundance with the mass, 24. 10.1 with 25, 11.3 with 26. You add them all up. And because these were percentages, you can divide them by 100. And there you go. That is your relative atomic mass. And this thing is called mass spectra. अच्छा, अगर ये मैं चार्ज बढ़ा देता, अगर ये +2 कर देता ना, तो अब mass to charge ratio चेंज हो जाता. अब वो 24 के बजाय 12 पे बनता, और ये 26 वाला 13 पे बनता, और वो दूसरा वाला 12.5 पे बनता, बिकॉज चार्ज +2 हो गया. और इनकी हाइट्स भी डिफरेंट होती, लेकिन उनका जो एरिया अंडर द कर्व है उसकी रेशियो अभी भी वैसी ही रहती. बट वी ट्राई टू कीप इट जस्ट +1 ताकि वो ज्यादा कॉम्प्लिकेशन में हमें जाना ही नहीं पड़े. ओके, सो it doesn't always have to be percentage on the y-axis. You can also have numbers of things, और numbers की ratio से पता चल सकता है आपको. You can also have ratios of things के relative amounts. मैं एक reaction करता हूँ, एक check करता हूँ, और उसमें दो isotopes आते हैं. एक जो है वो 100 है, दूसरा 200 है, तो उनकी relative ratio y-axis पे 1, 2 लिख सकता हूँ. And then I can use that to figure out क्या है, क्योंकि total area under the curve is 100%, या sum of all of that. ठीक है? So I can do all of that and I can figure out the relative atomic mass from that. तो हमारे पास जितने भी मतलब different particles आएंगे उनकी abundance हम naturally या उसको हम check कर लेंगे. We always consider the natural isotopes. We don't consider the isotopes that are man-made or artificial, because we need to consider only the ones that are stable. क्योंकि बाकी की तो percentages change होती रहेंगी, क्योंकि वो radioactive हैं या वो naturally exist नहीं करते हैं, किसी ने lab में बना लिए हैं, तो उनकी percentages ऊपर नीचे हो सकती हैं. So we don't consider those. So the first question that we get is, how do you calculate these things from the graph? Second kind of question that we get is कि आपको वो information देता है incomplete. आपको AR बता देगा और आपसे कहेगा कि बताएं जी इसकी abundance क्या है. So we will still use the weighted average process. Weighted average process ऐसे ही है जैसे आपके एग्जाम की वेटेज है. You are going to give 5 exams, हर एक की अपनी वेटेजेस हैं. तो आपके हर एग्जाम के जितने परसेंट होगा उसको वो उसकी वेटेज से मल्टीप्लाई करके आपका फाइनल ग्रेड देंगे. ऐसे ही हर आइसोटोप की जितनी परसेंटेज होती है हम उसको उसकी मास टू चार्ज रेशियो से मल्टीप्लाई करके फाइनल आंसर निकालते हैं, जिसको हम AR बोलते हैं. सो हियर्स अ क्वेश्चन. लेट्स से वो कहते हैं कि पोटेशियम के दो आइसोटोप्स हैं, पोटेशियम 39 एंड पोटेशियम 41, एंड दे आस्क अस what if the AR is 39.1, find the percentages that they have. So one thing that we know for sure is that the total percentage is 100. So we'll take this to be X and this to be 100 minus X percent. And then we'll know that, okay, 39 times X plus 41 times 100 minus X divided by 100% is going to give me 39.1. And you calculate this and you will get your answer. 39X plus 4100 minus 41X is equal to 3910. So 2X will equal to 4100 minus 3910. And then जो भी इसका आंसर आता है, I think 90/2, if I'm not wrong. Sorry, 190/2. You can obviously calculate it. So 95 aega. Yeah, so that means potassium 39 is 95%, which means that remaining is 5%. And provided there are only two such isotopes in the world. अगर वो different होंगे और तो उनकी percentage is different. So I'm going to give you a question. Try to do it. It's a really simple question, just like this. So I have silver. Silver के दो isotopes हैं. Silver 107 and silver 109. And I want you to calculate the relative atomic mass if these are the percentages. Okay, that's question one. And the second one is, if I tell you that copper has two isotopes, copper 63 and copper 65, and the relative atomic mass is 63.5. So which of these isotopes has what percentage? So two questions, try to do them.
Sir,
Yes.
for the first one, I got 107.97.
Okay. Yeah, that's right.
And like दूसरे वाले का I got 50.
That is not correct.
Yeah.
How do I know that's not correct? Because
क्योंकि copper is 64, I guess.
yeah, अगर वो 50% होता तो middle में आता आंसर. Copper 64 होता. Yeah, so one way we can easily figure out whether the percentages or where it's going to be is, especially for MCQs, is the method of ratios. So let's say I have two isotopes and one of them is a 63 and one of them is a 65. The number of AR, if this is like, just divide the distances between them. So this is 0.5 away from this and 1.5 away from 65. So the ratios are 0.5 and 1.5, यानी कि 1:3. तो we will, जैसे हम आयनिक कंपाउंड के फॉर्मूला में फ्लिप करते थे ना, रेशियो को क्रॉस मल्टीप्लाई करते थे, ऐसे ही यहाँ पे भी इसकी रेशियो और इसकी रेशियो परसेंटेज की 3:1 है, which means that this is present 75% of the time and that one is 25% of the time.
Yeah, sir, I realized I took copper 65 को गलती से copper 64, तो इस वजह से वो गलत आ रहा था.
That's okay. As long as you're able to understand what went wrong and you're able to fix that. So we can use different peaks and we will talk about molecular ions and molecular ion peaks later on. Abhi ke liye we don't need to go into that. And now I'm going to go to the past paper questions for this. And I would suggest कि आप उनको attempt करो. If there's any question, so I'm here to help.